Welcome back, ladies and gentlemen. Moving on 6.5, day 2. We're going to talk about the trig form of complex numbers some more, and specifically multiplying and dividing complex numbers in their trig forms, in case that's not obvious. Okay, well, multiplication of complex numbers. There's actually a really cool derivation for this, but I thought I'd save the time in the video and not put you through it. But here we go. If z1, so our first complex number, is some r times cosine plus I sine, just standard form. Same thing with the z2, same kind of thing. Alright, to multiply complex numbers together in this form, well, it's actually kind of a nice sort of thing. The first z times the second z, okay, again, that's just the problem we're trying to do. Okay, what's really nice is you take these r values and simply multiply them together. So it's going to be r1 times r2. Okay, and then we're going to get a big old brackety looking thing. Okay, and then from there, well, again, they're both cosine plus I sine sort of things, but again, theta 1 versus theta 2, so we are talking about different angles, but again, the nice thing how this guy plays out is all you have to do is cosine, and then actually just add the angles together. So it's theta 1 plus theta 2, cosine plus, same basic thing with the sine. You get your I there as per usual, and then it's sine of theta 1 plus theta 2. And it works out really, really nicely, really, really quickly. Okay, so just one quick example here. Let's use degrees. If I've got 5 times cosine 38, etc., and 3.2 basically cis, remember notation previous, 61. Okay, all we got to do to multiply those two guys together is take the 5 times 3.2, and then we're going to do cosine of 38 plus 61 plus I times the sine of the exact same thing, 38 plus 61. Okay, again, those are degrees right now, but here we go. Okay, then the 5 times 3.2, that works out to be a nice clean 16. And then again, I'll go drop to my cis notation now. So cis 38 plus 61 is a nice clean 99. There's my degrees. So very, very quickly you can get a result from there. Of course, if you need the standard form of that, basically just figure out cosine of 99, sine of 99, and then distribute the 16. And you'll have exactly what you need. Alright, here's another one, still a multiplication. Multiply. We'll just do this with radians, so no big deal. Same basic idea, we take 7 times 3, of course that's, let me check my calculator, about 21. And then again, let's just cut to the chase here, cis, okay, my first angle is pi over 4, plus my second angle is 4 pi over 3. And then again, basically just do what it says to do here. Okay, 21, cis, and then again, hopefully you can work through this without too much trouble, but it's basically 3 pi and 16 pi all over 12, and 3 and 16 works out to be 19 pi over 12. Okay, hopefully that looks like a 19. And there you go. Again, if you needed the standard form, basically just simplify it down. Okay, well, division of complex numbers, as you might guess, works a lot like the multiplication, but a little tweak here and there. This kind of reminds me of logs, actually. So again, if I've had my same two just generic complex numbers here, okay, in order to divide them, well, instead of multiplying the r's, now we're dividing them, and then instead of adding the thetas, we're going to subtract them. So there you go. So something like this, we simply have to take the 12 divided by the 8, just again dividing by the r's, and then just take your cis, and now we're going to subtract. So now 72 degrees minus 45 degrees. Fine. Okay, so the 12 over 8, that reduces down to a 3 over 2. And then I got my cis, and then 72 minus 45, hopefully works out to be about 27. And I guess I didn't need the parenthesis there, but there you go. Simple as that. Alright, so just another one with radians here, just to kind of cover all bases. Again, so again, you got the 8 and the 2. Okay, so I mean, written this way, it looks pretty obvious that you're going to need to reduce those, but just for the sake of argument, there you go, 8 over 2. Again, there's my cis, and then again, I got to do 7 pi over 6 minus pi over 2. Okay, of course, that pi over 2 is really like having 3 pi over 6. Okay, so basically, 8 over 2 reduces to a 4, and then I've got my cis. And then 7 pi over 6 minus 3 pi over 6 is 4 pi over 6. And hopefully this is just screaming at you right now, like, hey, I can reduce that. And so of course I will want you to reduce anything that is reducible in that fashion. So this becomes 2 pi over 3. Okay, there's going to be a batch of problems in the assignment where here's basically what the directions look like. Okay, we're going to have some kind of an operation there, and we're going to write the trig forms of the complex numbers. So we'll be the standard forms, and I have to go to trig forms. Okay, we're going to perform the operation using the trig forms, then do the standard forms, and check the results versus what we did in the previous part. So here we go. All right, so again, first thing, part A, basically, I want to get the trig forms. Okay, so I've got 4 minus 4i, so one thing you might want to do is just kind of draw them out on the side. So 4 minus 4i, of course, is 4 to the right and 4 down. And then quickly that should let you go, oh, look, it's a nice 45, 45, 90 triangle. For lack of directions, I'm going to do these using radians. Alright, so radian-wise, that's going to be a 7 pi over 4. And of course, if I'm going 4 horizontally and then 4 vertically, and again, right now I don't really care that it's a negative 4, since I have 4 and 4 as my two legs of my triangle, that works out to be a 4 root 2 as my r. So basically this works out to be 4 root 2, my r, and then good old cis of 7 pi over 4. Okay, then, the other half of that is the 7 plus 7i. Okay, conveniently, these are the same number twice again. So I'm going 7 to the right and 7 up. So again, finishing my triangle here gives me a 7 root 2 as the hypotenuse, and this one works out to be a very, very nice pi over 4 angle right there. So the other half of this guy is exactly what I have over there, 7 root 2 cis of pi over 4. Alright, so there's basically your answers to part A. Let's move on. Alright, now part B, we're going to perform the operation using those trig forms that we just figured out. So I've kind of cheated a little bit and I've copied them down already. I'm sneaky like that. Alright, but again, just doing the operation right now, all I want to do is multiply the two r values. So 4 root 2 times 7 root 2. And then again, cosine plus I sine of adding the two angles together. So 7 pi over 4 plus pi over 4. Okay, and of course then just cleaning up the mess that we have here. Okay, so the 4 times the 7 makes a 28. Their 2 root 2's go together to make a regular 2, so really 28 times 2 is a 56. And then I've got cis, and this works out to be 8 pi over 4, and just to save time, I'll write that as 2 pi, because it reduces very nicely. And you might look at that and say, hey, wait a minute, couldn't you do a little better? And, well, I agree with you. I don't know if one is necessarily better than the other, but this would then be 56 cis with actually an angle of measure of 0. Again, I don't know if one of those is necessarily better than the other, so if this ever happens, I will accept either one of those as the final answer. Now, part C is, to me, kind of two different parts. I'm doing the standard forms and then checking the answer, so here's kind of part C1. Okay, using the standard forms. Okay, now, unfortunately, with the standard forms, we have to resort to basically what we did in Algebra 2 and kind of do a FOIL sort of thing. So, regular FOIL, I get 28, I get a plus 28i, I conveniently get a minus 28i right there, and then here I get a negative 28i squared. Okay, well, very nicely these two guys cancel out in the middle, and then the negative sign here gets together with the I squared, which remember is negative 1 to kind of make a plus. So really what I have here is a 28 plus 28, and checking my calculator, that tells me it's 56. Alrighty. Alright, so now the second part of part C says check the result against part B. Okay, again, I cheated a little bit here and wrote these answers out. Okay, our standard form we just did, we got a 56, and then the trig part in part B is 56 says 2 pi. You may be like, well, is that really the same thing? And, well, basically what we can do is just work this out to be sure. Okay, so again, I'm going to abandon my cis notation for the trig part and go with cosine 2 pi plus I sine of 2 pi. A little bit to work these things out here. Well, of course, thinking of my unit circle again. Alright, 2 pi, of course, is the same thing as 0, as I said just a little bit ago here. Alright, so since that's the point 1, 0, my cosine is 1 and my sine is 0, so this becomes 1 plus I times 0. Okay, so distributing here, I get 56 times 1, which is 56, and then of course, since I got a 0 involved here, that is a 0, so actually that does work out to be 56 compared to the other 56, so I'm happy. Alright, so basically there it is, just verifying those two are actually the same, even though the trig form kind of looks a little bit different when you get done with it. If you do simplify it out, you should get the exact same answer. Alright, yeah, I bring this one up now. Okay, under the same directions, I have parts A, B, and C1, C2. Alright, well, one thing you might notice is on the numerator, again, that's a nice happy one that I'd be able to find a nice trig form with nice pretty unit circle values associated with, but, wait a minute, that one, not so much. So basically the moral of the story here is we do basically what I just did, but what you'd have to do is use kind of a messy sort of angle measure for this. So it's going to be decimals and you have to use your calculator heavy. So messy angle, so heavy calculator use on a problem like this. I won't bother doing it because I'm sure you don't want to spend another 5 to 7 minutes watching me do this one problem. Alrighty, and there's the assignment. So nothing much less to say other than, I'll see you in class and ask me any questions you have.